Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try a project you hear about on the show, you'll need somewhere to deploy it, so take a look at our friends over at Linode. With the launch of their managed Kubernetes platform, it's easy to get started with the next generation of deployment and scaling, powered by the battle-tested Linode platform, including simple pricing, node balancers, 40 gigabit networking, dedicated CPU and GPU instances, and worldwide data centers. Go to pythonpodcast.com/linode, that's Linode, today and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. And do you want to get better at Python? Now is an excellent time to take an online course. Whether you're just learning Python or you're looking for deep dives on topics like APIs, memory management, async and await, and more, our friends at Talk Python Training have a top-notch course for you. If you're just getting started, be sure to check out the Python for Absolute Beginners course. It's like the first year of computer science that you never took, compressed into 10 fun hours of Python coding and problem solving. Go to pythonpodcast.com/talkpython today and get 10% off the course that will help you find your next level. That's pythonpodcast.com/talkpython, and don't forget to thank them for supporting the show. Your host, as usual, is Tobias Macey, and today I'm interviewing Eduardo Schettino about Doit, a flexible and low-overhead task automation tool. So, Eduardo, can you start by introducing yourself?
My name is Eduardo. I'm from Brazil. For the last 10 years, I've been living in China.
And do you remember how you first got introduced to Python?
My background was study electrical engineering, and I was mostly a C++ programmer. And then at some point, I started to try out different languages. And then I heard first about Zope. And then I tried out, and then I started using Python for some small scripts. And then on a job, it was not related to Python, but I set up like a roundup, like the bug tracker that Python uses today. And then I decided my next job must be Python. And then after that, I just applied for Python jobs. And then I landed in web development with Twist and Django. And then I never looked back from there, just Python.
That brings us now to the Doit project, which you started a number of years ago. I'm wondering if you can just describe a bit about what it is and some of the story behind how it got started and why you decided to build it yourself and what motivates you to keep maintaining it.
Coming from like a C++, I enjoy Python very much. But in the beginning, I have this, there is no compile step. And then I quickly found out about PyFlakes. And that was very nice to run PyFlakes before you try to run your program to find like some basic syntax errors. And then I thought, maybe I should put this in a build too, because I don't want to run PyFlakes on my whole code all the time. But the problem with the traditional build tools like Make is that like it compares the timestamp of your target build files, the object files with the source. But when you're running PyFlakes, it's just a checker. There is no output file. So just because of this small change, the traditional build tools could not handle. And that was the basic idea that started to trigger. Like I say, I want to build something that I can just handle more generic tasks, not only build things. So that's why I put the name Doit. It's just like Make, but it's more generic for executing any kind of task that you want to do in an efficient way. And then at first I tried Scons as well from Python, but it also couldn't solve the problem. And then I started with a very basic script that I was starting to add more and more features until Doit came to life as a separate project.
For people who are first coming across the Doit project and trying to decide if it's something that will be useful for them, I'm wondering if you can just talk about sort of the main goals and use cases that it is aimed at and some of the ways that people might integrate it into their workflows.
For example, Make. Make is like if you talk to a developer, C++ developer, because compilation times can take 1 hour, but when you start using a build tool, it can go down the time because it's more efficient. It knows what changed and what can be done. But most of people know Make from just installing programs. They just like untar, configure, make install. So a problem that I have in the beginning to describe Doit is just like, it's kind of build tool. But many people think, but a build tool, they don't know about this concept of incremental builds, of executing only what's necessary, what's not up to date. And the other problem describing it is like, oh, it's a build tool, but Python is you have no build step. So the way that I tried to market it, it was quite hard. But now it's more common, the concept of it's just a task runner. So basically, over the time it grows, it can be used like from three different ways. I would say is like the most basic way is similar to Make, that you have like in Doit we call a do file where you describe your tasks, and that's just like to manage the life cycle of your project. For example, I have a web project. I can use it like to run some lint checks, to execute the tests, or to build some static assets. But over the time, do it also grow to be able to be used like as a framework. Like if you want to develop your own application, you can use Do It as a framework for your application that will have all the powers of a build tool. One example for this is a project called Nicola. Nicola is a static site generator, and it's based on Do It, and the command line, everything, it's based on Do It tasks as Do It tasks. So the Do It goal to scale down should be able to be used as a simple task runner, or you can also scale up to applications as well.
As far as the actual implementation of Do It and the ability of it to be used as a standalone build tool or as a component of a larger framework, I'm wondering if you can talk to some of the design elements and the architecture of the project and some of the ways that the current state has evolved from where you first began it.
So when I started to design it, the main point was, as I said, I want to build like a build tool that would not require targets. Like you have the input files and you have output. But there is other things that I want to tackle. Like, for example, when you use Make, it's not a proper language, so it's kind of very limited what you can do. It's quite powerful, like the regular expressions for defining rules. But once it starts to growing, it becomes very hard to debug and to create your own rules. One thing that you can see from that is like you have to start to have programs that generate your make file. So you start kind of losing the purpose. Like you have a very compact format for defining your tasks, your rules, but then it's not powerful enough. And then you have to create a different program to generate those formats for you. So one goal that I have for Do It is that this should never happen. When you are defining your tasks, you should be able to do everything at once without resorting to generator or macros. Another thing that I had in mind is about readability. There is a bunch of support tools that comes with Do It. It's not just for running. Like you can list the tasks without having extra effort. Once you define the tasks, you can generate like a graph of the dependencies of the tasks. And you can get information about what's the status, if it will run or not, or what's the reason if it's not up to date. And yeah. So another aspect of the implementation is that I wanted to make it very easy to get started. So at the time, I was writing tests with Nodes and PyTest. So I decided to go to the approach similar to PyTest, where on your Python module, you define any function that have task underscore. Do It will understand that this is a task definition. Another important factor, I would say, is that Do It is designed to be used by developers. So you define your tasks in Python code. Although programmatically you can write Python code to define your tasks, the tasks can be described by a simple dictionary. So it makes much easier for introspection and for understanding the relation between the tasks. So when you write your first tasks, you don't need to import anything from Do It. You just define some basic functions that return a dictionary with the task metadata.
In terms of the sort of design philosophy, you mentioned that it's targeted for developers. The way to interact with it is just by writing arbitrary Python code. I'm wondering how you've thought about some of the sort of programmatic constructs that you expose and some of the ways that you have designed it to be composable and evolvable so that it is sort of powerful and easy to get started with while also being extendable and able to grow with the project that it's embedded within.
I guess one of the easiest ways is just like I try to keep it as much as plain Python as possible. It's like your code for the tasks, you don't really require to use anything from Doit itself. Doit comes when you attach metadata to your tasks. Like Doit have the concept of actions. Actions is like can be Python code or a shell command. And then you attach some metadata about the file dependencies or dependencies to another task, or how to pass information from one task to another, or to get variables from the command line. Most of your code is just plain Python. And then you can use all the basic Python constructs you use normally. There is no much difference.
In terms of the Doit project, as you mentioned, it's a tool for task and build automation, and Make is the sort of canonical example of that. It's been around probably the longest, at least in terms of tools that are still being used today. But there have been a number of other projects that have started up within the Python community as well as outside of it. So from Ruby, the most notable is Rake, but within Python, there are tools like Click and Typer, and then there's the Invoke project that grew out of the Fabric project. I'm just wondering if you can talk about some of the ways that the Doit tool compares to some of those other systems that are available, and if you can just give your sense of its position in the overall market and some of the reasons that somebody might want to choose it over some of the other options that are out there.
Click and Typer, they're basically frameworks or libraries to help you build command line tools. That's really not the goal of Doit, although it can be used in this way. It was never the goal because Doit expose some other commands and you won't have the same flexibility you have if you use Click, for example. There's some people do some programs with Doit and then they wrap up for the user interface with Click or another argparse or whatever. Regarding Invoke, Doit is about the same target people, same target usage. My opinion is that Invoke doesn't have this execute something only if it's not up to date. And this is the essential feature that Doit have from day one. And I think sometimes for some people who doesn't need that, it might be okay at some point, but it doesn't let you scale. So that's the problem I see with it. Doit is also compared to other tools, like because Doit is used for a very wide range of applications. When I just released Doit, most people who started using was like comparing Doit to Puppet and Ansible and Chef for some basic setup of their machine. It's okay if you're doing it only on your machine, but Doit doesn't have like the capability of Bootstrap itself. But for your own project, it might be reasonable. Doit is also used a lot in the scientific community. And there are some other tools that people compare, like SnakeMake. I'm not that familiar with SnakeMake. SnakeMake is more like completely programmatically, as I understand it. And finally, nowadays, some people compare Doit to Luigi or Airflow. Doit is command line only, so you have advantages and disadvantages over Airflow in this aspect. I guess the original reason that I created Doit is the capacity to check when a task is up to date or not. This is mostly neglected by most other tools still today. And I see a lot of people who use Doit, they stories like this. Oh, I tried this tool, then I tried that tool, and then I tried that tool. And then after they try everything, they try Doit and said Doit was the only one who could handle it. And usually the user's report is the only tool that can handle anything that you try to put at it, because it was really built to handle any kind of task. And that's how it evolved. Like I got people working with like circuit design or some things that I have no idea what it's about. And it's like, oh, I need to make this. And then that's how it evolved. And this is one thing that I always took pride. That's my priority is like, if someone have whatever condition that they want to have a task that should not be run, Doit should be able to have a way to figure out.
In terms of the history of the project, I was looking back to see when you started, and it's been running for about 13 years now. So there's definitely been a lot of evolution in the project and evolution in the Python ecosystem. And I'm curious if you have any thoughts about the overall philosophy as to how and when to add new features and when to try to kind of push them into maybe an extension to the Doit project so that the core remains lean and evolvable, and just some of the practices that you have brought into the maintenance of the project that has allowed it to sort of survive and thrive for this long.
The project was very much, I would say, community driven, not by their development, but by requests. And one project that was very important for Doit history was Nicola. A lot of the development that happens was to support the Nicola project. In terms of Python features itself, when I did my first release, I created my own website and it was horrible. And then the second release, the Phoenix come out, the documentation, that makes all the difference. So even something that today it might seem trivial, because like even me, I couldn't look at the website because it was so horrible. And then Phoenix make it beautiful and easy to create and the documentation. And then generators was a big change that I had on my code base. After that, multiprocessing, when it came out, I added support for parallel running with multiprocessing. And I still to integrate async.io in some way. Yeah, but basically that's it.
As far as the overall ecosystem of the Python language and some of the new capabilities and features that have been added, particularly since the official deprecation of Python 2 version, and some of the shift in focus of the overall community to having a large contingent of data scientists and data-oriented workflows, I'm wondering how that has influenced your thinking about ways that Doit is applicable to people's usage and maybe some of the language capabilities that you're able to incorporate into the project, or some of the ways that the overall ecosystem around packaging or builds and releases has impacted the work that you're doing on Doit and some of the types of features that you want to build into it or use cases that you want to enable.
That's interesting because like I actually built Doit with a focus on testing, because I wanted to run PyFlakes. And I remember my first project, I had a Django and Twisted. They have like a different set of tests and different modules. And I have like JavaScript tests and I want something to drive them. But I think I'm the only person who really Doit with this goal of making testing more efficient. And through the years, Doit was picked by different communities. And like when I created Doit, there is nothing about data analysis and pipelines. But I don't know how you heard about Doit, but it seems that this community is picking up. First was people doing blog generators and documentation websites, and then comes the scientific community, and now the data analysis and machine learning. I think it proves like the tool, even though I have never thought about building data pipelines on it, but it's generic. So people just come and new communities come and discover it and applies to them. For me, it's very nice that Doit still can compete with tools from each community, that they build a specific tool, and Doit still can find some people who thinks it's worth it.
Yeah, I actually first came across the Doit project when I was first starting the podcast and was looking at what website I wanted to build. And so initially I actually used a Pelican static site generator and was also looking at Nicola, and had the maintainer of that project on the show a while ago, which is how I first came across Doit. But now I actually spend a decent amount of my focus on sort of the data engineering space. One of the main abstractions there is the idea of the directed acyclic graph, or the DAG, which I know is also what Doit relies on internally. So it's a tool that definitely fits very well to that workflow.
In terms of evolution of Doit, like I think maybe you're going to cover this later, but one thing that I would like to build like a proper UI interface, like in a browser, integrate like a continuous integration system, or to drive pipelines to be more like Luigi and Airflow. But I just don't have the time and resources to dedicate that. But I know some people use Doit as a task inside of those kinds of pipelines. But I see no reason why it couldn't be something that you use both on your command line and also on a richer user interface in a distributed system.
And for people who are using Doit, I'm wondering if you can talk to the overall workflow for getting started with it, starting to integrate it into the development process, or being able to define different tasks and their relation to each other, and some of the types of metadata that you're able to track to determine when or if you need to actually execute a particular stage in that execution graph.
So for people who is not familiar at all with Doit, I usually say, first get your code working without Doit, because Doit is just like something that you can use to cache your results or to parallelize your execution. So, but first you need to have whatever your business logic working by itself. After that, oh, maybe this calculation is expensive and I don't need to do it all the time. And then you extrapolate it to a task. Then you go on, you just say, whatever you think it fits to be executed independently, you go and extract it to a task. Or if you're starting with like more for a project management, you just create one task for each different thing you want to do. And starting with Doit itself, it's very easy. Basic task definition, the only thing you need to define is actions. Action is just some Python function or a shell command. And then after that, you can just start growing whatever you need. You can add like file dependencies. That means whenever a file change, you need to execute the task, a target that says that like the target must exist. And the basic check is just only if a file was modified and the target exists. But you can also define custom functions to check if a task is up to date or not. You can integrate task values from one task to another. You can have tasks to be dynamically created, and it goes on.
Being able to dynamically generate the tasks is definitely particularly applicable to data-oriented workflows where maybe you want to ingest some piece of information and then based on some operation that you do on it. So maybe you take a CSV file and you split on the number of rows, and then for each row you want to do some other downstream task, and then being able to do sort of fan out, fan in topologies. I'm curious, what are some of the other ways that you're seeing some of that kind of dynamic task graph building used maybe in web or testing or build and release use cases?
There is many different use cases. Like there is sometimes even before the build, you know what tasks should be, but you have a very large number of tasks and you don't want to be build the whole DAG every time you do it in the command line. So you can delay that. Give an example, maybe you get a file from the internet. After you get the file, we'll check whatever other dependencies or calculation needs to be done. I also use like for testing, like for example, I first analyze your source code to define which order I should be executing something. Even like for, although you do it is usually not used for C++ compilation. Like once I built, just for fun, I built a compiler for C++ and I was looking at Scons implementation. And Scons have like a construct for you to build your own rules. But if you try to use their API, you will not be able to reproduce their C compiler because under the hood, you do some stuff that is not exposed in their API.
In terms of being able to build reusable task flows, I'm wondering what you and the community of users have been able to design or build for being able to say, this particular set of tasks I want to run in every Django project that I use, but I don't want to have to copy and paste this code everywhere. So I want it to be just a pip installable package, but I also then want to have some bespoke tasks that are specific to this other project, and just some of the ways that people are managing those reusable and those
custom elements in different projects?
Usually the main build part is just like Python functions, so it doesn't matter. The tasks itself is just a dictionary that you can pass around, and a function that can create as many tasks as it wants is just like a generator yielding many, many tasks. So for example, the Nicola project, again, it has like a plugin architecture that they have their own database. So for example, a plugin can register a task that it says, oh, this task will modify the home page. So you make sure that this task is executed before the home page. Everything is just like plain dictionaries. It's easy to integrate even the code that you're not aware of. But for the very basic tests, it's trivial. It's just like a function that return a dictionary, just plain Python. You put in a model, import it, and you execute it.
In terms of the sort of discovery of tasks that are present in a code base, I know that, for like Rake, you can use Rake-T and it'll say, these are all the tasks that are available. I'm wondering if you have something analogous in Doit so that you can come into a new code base and see what are all the tasks that are available for me to run, maybe include some information about, maybe like some help text about this is what it will do, these are some of the inputs that you might need, or this is the relation to other tasks within the overall task graph, so that as a developer I can say, okay, this is what I can do, but I now want to do something that is an additional stage after all these other steps, so I know where to hook in, and just some of the kind of developer conveniences that are available for people who are coming into an existing code base and want to extend it.
Doit, it have like several commands. The default command is to run, but it also has a command list that will list your tasks. And the command help will work for each of the tasks. So you can write documentation for each of your tasks and about parameters, how it's used. And you can get info from a task to show more information about its metadata, why it's updated or not. Doit can also generate tab completion for your tasks. So it works for Bash and Z Shell. And there are plugins as well. There is a plugins that generate a dot file with a graph. And now just on this release, under a request from the user, you can now attach some metadata to your task that Doit doesn't use itself. Because Doit is also extensible through adding new commands to manipulate your tasks, something different than running. So this guy was building something that he wants to classify different tasks by some tags that he's using. So it's also very easy to extend Doit in this way that you can build new commands that get the task metadata.
As far as the sort of debugging of tasks where maybe you accidentally introduce a cycle into the task graph, or you are iterating on adding some new functionality to a task that's maybe in the middle of the graph and it ends up breaking some of the downstream flows. What are some of the useful debugging techniques or some of the design patterns that you've seen people use for being able to have some level of kind of resiliency, or some of the testing approaches for ensuring that tasks remain operational as people are evolving a code base?
So since Doit is plain Python code, you can just put a debugger breakpoint there. And even you can run Doit with PDB mode, that whenever there's an exception, you drop into the PDB. There is one user of Doit, he mentioned that the graph plugin was useful for him, that after defining a new task and he noticed there is some problem in his definition just by looking at the image. But this is a hard problem. Sometimes it's just through debugging.
In terms of your own work, I'm wondering if you can talk to some of the ways that your usage of Doit has evolved, or some of the most useful workflows that you have built out for your own applications of Doit within the different projects that you have focused on over the years.
In the beginning, when I created Doit, my main focus was really for testing. I actually at some point created my own continuous integration system. And yeah, nowadays I'm not a heavy user of Doit myself. I have it in all my projects, but just simple stuff. I know people do much more interesting stuff than me. one project that I like done by myself. It's a PyTest plugin. It's called PyTest Incremental. And it's just basically the idea is that it will analyze your source code and all your imports, and it will execute only the tests that were affected by the change since the last successful run. Another thing that I think is very important in PyTest is that how it orders the tests that you execute. PyTest by default is like alphabetical order. I think it's not the best way. So also try to create a DAG from your source code and try to execute from the leaves. Because if you break something from the root, because if something is broken on your basic core of your code, usually it will start getting hundreds of errors if you have a big test suite. But you want the first failure to be the most significant, because if you're testing some code way down dependency tree, that failure of the test probably be meaningless for you. Not only that, but you have wasting your time testing some code. So this is something that I think mostly no one do, but I think it's very important when you have a large test base that you execute your tests in the right order. And Doit will do analysis of all your imports and say which order the test should be executed. And so your first failure is fast and significant.
As far as being able to enumerate all of the import sequences and the dependency graph there, I'm wondering if there are any particular libraries or tools that you found useful for that.
At first, I was using, I forgot the name. I think it was Snakefeed. But in the end, now PyTest used one library that was created by myself. I think the name is import depths. I might be wrong. So I think when I migrated to Python 3, I had to write my own library.
And then on the caching layer, because of the fact that Doit allows you to understand, okay, this task has already been executed, there's nothing that's changed here, we can just skip that. I'm wondering what the options are for being able to plug into that layer, particularly for the use case that you were discussing of maybe adding a UI on top of Doit so that it can execute in somewhat of a distributed fashion so that you can say, locally, I'm just going to use, local file system for the caching, but if I'm running in a distributed context, maybe I want to use Reddit or a database so that I can parallelize across multiple machines for being able to execute these tasks.
Doit by default use DBM. DBM is included in the standard library. It's fast, but it's only local. It also have the options to run on a plain JSON file. It's have some advantages, but usually have disadvantages because it's very slow in the end of the process to close the file. And Doit also comes with support for SQLite. SQLite allows parallel executions from your command line, but also have some disadvantages. This backend is like there is a interface for it. There is a plugin written for Redis. I myself never used it. But the backend, it's basically any key value store can handle it. This database, it contains not only like the timestamps, the hash of the files, but it also contains intermediate values. So for example, if you have one task computing whatever, and you want to use this value in a different step of the process, you don't need to create intermediate files. You can just put it in Doit database. This comes automatically when you return this from your task.
In your work on building Doit and maintaining it and working with the community, what are some of the most interesting or innovative or unexpected ways that you've seen it used, or some of the most interesting projects that you've seen built on top of it?
This is hard. People usually don't come back to you to tell how they are using Doit. Sometimes I see quite a few scientific articles mention that they use Doit. Some big names that they wrote back to me that I heard, it's about a company called Atomwise. They do like chem informatics. It looks pretty cool. BMW used for designing the panel of the cars with their contractors and everything. And there is an open source project called MetalK8S. It's like they build the ISO for Kubernetes distribution, and it's based on Doit. That's the ones I know of.
And in your work on creating the Doit project and maintaining it and using it in your own work, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
Definitely, documentation was really challenging. First, like the tool itself, many people have some problem getting like, okay, it's called Doit, but what does it does? What does it does? And then you need to introduce what its capabilities. And although the basic usage is very simple, it grows to have a lot of features. So you have to write a tutorial where people can get started fast, but still hiding some complexity and showing the benefits. And a lot of the documentation I get when people start asking the same thing many times, I say, oops, the documentation is lacking on this. And just marketing is like very hard. I don't know how to do it, how to advertise it.
For people who are considering Doit or they're looking for some tool to handle some of their task automation or build automation or just running arbitrary steps, in or out of sequence, what are the cases where Doit is the wrong choice and maybe they're better suited with a more custom built framework?
I would say like if what you want to do it's very specific and there is already a build tool to handle that, like if you're compiling C++ code, just go through Scons or CMake or whatever. And also, if you do it as a command line tool, so if you're doing, I know some people do very long pipelines on it, but if you have like some very long pipelines on it, some distributed or UI, I would probably go with Airflow or Luigi or other in this area.
As you continue to maintain the Doit project and use it for your own work, what are some of the things you have planned for the near to medium term or any areas where you're looking for help or contribution?
Myself, I want to revisit the idea of using Doit in a continuous integration system. I'm trying to do a GitHub Actions integration. So you can do only what's necessary on GitHub Actions. That would be useful for teams if you have like a build that takes like 3 hours. It's not like, it doesn't matter because it's my machine. It matters because it's a very long time, even for a CI to do. So if you get this Doit support out of the box on GitHub Actions, I think would be a big win.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And so with that, I'll move us into the picks. This week, I'm going to choose the Matrix series of movies. I started revisiting them recently because there's the new one coming out, and it was rather hilarious watching the first one again now that it's a little over 20 years since it first came out. So just looking at some of the technology that's in there and some of the thoughts on sort of their representation of the future now that we're living in parts of it is definitely humorous to see. So definitely recommend revisiting that series or watching it for the first time. Good fun. So with that, I'll pass it to you, Eduardo. Do you have any picks this week?
I'm recently watching John Pilger documentaries. They are all very good, very insightful and surprising.
Well, thank you very much for taking the time today to join me and share the work that you're doing on Doit. It's definitely a very interesting tool and one that is very useful and valuable for developers and people working in various aspects of software. So appreciate all of the time and energy that you've put into it, and I hope you enjoy the rest of your day.
Thank you very much. Thank you for the opportunity to talking.
Thank you for listening. Don't forget to check out our other show, the Data Engineering Podcast, at dataengineeringpodcast.com for the latest on modern data management. And visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts@podcastinit.com with your story. To help other people find the show, please leave a review on iTunes and tell your friends and coworkers.